Oviya, start.
Okay, sir. Is
Start.
Yes, sir. Good
Okay, good
evening,
morning, madam.
sir.
Okay, okay. And just I'm start the introduction. Okay, welcome to all the participants for this international SDP on Learn Python for a Bright Career. Today is the day 5 session. Now I request our resource person, Madam, to hand over the session. Madam, you can.
Thank you very much, sir. Thank you very much, sir.
Right.
Greetings, everyone. Good evening, everyone in India. Reverend dignitaries of the great institution, respected HOD, sir, of the EC department, dear Dr. Arun, sir, dear Mr. Ravi, sir, and all the dedicated Nobel professors capable of becoming Nobel laureates, and all other staff members, and as always, my dear darling curious kids, Andriki Namaskaram. Happy Friday to you all. On the first day, I thanked my teachers. Second day, I spoke about my school friends. Third day, I was proud of my father. Yesterday, I had asked all you kids to learn well and utilize your resources well. Today, I would like to make my college friend, Mrs. Chandravardhana Sampath Kumar, special by thanking you, dear Chandra. Tangamaila, I'm in fact praising the innumerous women across India and elsewhere around the world for their choice to be a homemaker. This lengthy list actually, also includes my own dedicated, lovable mother who chose to stay home to raise me and my brothers good. Honestly, the most toughest job is being a stay-at-home spouse or parent. Let us appreciate the dedication of such women as they are the queen of your household. Me inti Maharani, Garkirani, Ungvitarani, in fact, Sami. Please be extra kind to them as they deserve the most love and affection. Since these homemakers are like Mother Earth that both revolves and rotates around everyone in their family. Okay, to make the family members shine like the sun, please always show the cooler side of the sun to your earth. Okay, that's funny, right? Hope you are all doing well. After that laugh, since the next hour or so is going to be extremely interesting. Okay, super. Artificial intelligence, AI, is making machines smart. In order to perform tasks that require intelligence of a living being, so far we have never been able to surpass the brilliance of a human being, meaning what we call as AI so far is mostly specialized AI. Artificial general intelligence is still in its primitive stages. That's why we should be proud of being a human being. There is no robo, no AI system better than us in the world. So far, we might have heard about, some chess playing robo, some, like a Go playing robo, so many other specialized robos, but they are not, as general as we are. We can multitask, but they cannot. All right. In addition to data science presentations that I promised yesterday, just for you all, to understand AI, my dears, I will forward a set of 50 slides from another webinar that I took on artificial intelligence through Dr. Arun sir. Okay, now, in this slide, we see neural network. Okay. Sometimes I would be a little bit slow when I'm talking so that, based on, how much content is there, or when there is a code, I would slow down a bit so you can actually review. When there is, no need, then I'll be in my normal pace. So please understand that. So neural networks is a set of neurons organized in layers. You see that there are layers in this slide that you see. Each neuron is a mathematical operation. Its input is multiplied with its weights, and the output gets passed to the other neurons through the activation function. In the practical part, we'll be going over neural networks in TensorFlow and Keras in depth today. Okay, so other than that, whatever is in this slide will be notes for you. All right. Perfect. Slide number 3. Some of the machine learning algorithms are grouped here based on their usage. This slide was prepared based on the collection of cheat sheets. Its link is mentioned on the bottom. I know that some of the letters are very small for you to look at, but this will be your notes. You can always go in the cheat sheet. Today, I have the file format. I will forward that to sir. That I have it as a single PDF, I will forward that to Dr. Arun sir, and then he can actually send that to you. That has so many cheat sheets related to AI, machine learning, data science, big data, all of that. All right. Okay. So clustering, at least if you see the bigger words, clustering, the bigger blue words, that's good enough. Clustering algorithms are unsupervised in nature. They automatically discover natural grouping in data. Clustering helps with whenever you need data analysis activity. It helps with data analysis as it learns more about the problem domain, resulting in pattern discovery or knowledge discovery. Other than that, we have the k-means listed in this slide. Gaussian algorithms are also the clustering algorithms. There are no best clustering algorithm. There is no easy way to find the best algorithm for your data without using controlled experiments. See kids, I'm not sure if you noticed during the practical part, again, like I said, I want to speak a little bit slower so that, you can follow the code, and then you can always execute similar code. You can pause and make a note of it. However, during the slideshow, I tend to be a little bit quicker. There's so much here to talk. So anomaly detection is what we see the next. Okay. Unusual data points. KNN is the simplest, even though not mentioned in the slide. For a particular data point, its distance to its kth nearest neighbor. Okay. Other than that, we see regression algorithms, means predicting. Mostly from the start, you see the predicting values. So if you just look at that, so linear, regression is supervised, unsupervised. These are all the terms that, reinforcement learning. These are all some things that you need to know. So in the slides that I'm going to be sharing with the sir, there'll be more details in case you don't understand the basics, because we only have 1 hour window and we're focusing on specific modules that are in Python. So, okay, sorry, kids. Let's just keep on going. Bayesian, Bayesian neural network. Okay, that is widely used since it supports an incremental learning technique where subsets of data, all right, subsets of data are loaded into the memory for computations in each increment. That is why it's famous. Otherwise, what happens is some other algorithms take in all of the data, and it's so humongous. All of the big data is so humongous, and it keeps that in memory, and it just models, tests the model, and it kind of is an overhead for the system. That is why Bayesian, since it's actually using the incremental learning architecture where subsets of data are loaded into memory, this is famous. Bayesian, neural networks are famous. Multi-class classification is supervised. Scikit-learn Python library has a lot of classification methods such as decision trees, support vector machines, etc. Generally, in multi-class classification, we train a classifier using training data and use that classifier for classifying new examples. Okay, as such, the most popular machine learning algorithms are all linear regression, whatever you see here, logical regression, classification and regression trees, k-nearest neighbor, knn, naive Bayes. Okay, please try to know more on them by practical application. We need to see things, how these things work, or ideas. Don't worry, it'll be easy after a few times, when you look at them. Let's move on to the next slide. Okay, slide number 4. Nice. Gradient descent. What is this? We understand that in machine learning, some data points are taken, and these data points are passed as parameters to the functions repetitively. Okay, repeatedly we keep on passing these data points until the function gets a good approximation or understanding of the data. We keep on repeating this process. To get an accuracy of this approximation of data, what we do is we find the deepest valley. We start somewhere and we try to descend down. Descending the valley is called gradient descent. Okay, I have expressed in the most simplest words that I could. If you want to review, you can always go back to my video and then repeat it over and again. This is the most simplest way to explain it, as far as I know. Okay, otherwise, the deepest valley is the best set of parameters of the function for your data points. This determined accuracy is called as the loss or the cost function. Usually, wherever you have the deepest point, right, that has the most accuracy and the lowest loss. Wow, I know. Yeah, so much of technical talk. Stochastic gradient descent. Okay, it's simple yet efficient as it's used to train a wide range of models. Stochastic gradient descent upgrades one sample at a time. The term stochastic comes from the fact that the gradient based on a single training sample. That is why it's given the name. Okay, this is an stochastic approximation of the true cost gradient. Sounds very statistical, I know. I have specified a YouTube link right below, you see, for you to know more. Okay. All right. So that's step by step. It's about a 30-minute or 25-minute video, so it's beautifully explained. That's why I put in there. So you can always refer that. Now, back propagation is some other word that you can say. What happens is it computes the gradient of the loss function with respect to the weights of the network for a single input-output example. So this is all the most simplest way to explain, but there's much more calculations. The only way that you're going to know about this is get yourself used to playing with data that's already available. I'm going to be showing you a lot of sites today pertaining, and then you can actually see how they have explained. So we're going to move on to the next slide number 5. Fantastic. There is a link to an awesome article. You see the link? Sounds like an Indian name. Yes, definitely. Backpropagation and how it works is explained step by step. My dear cuties, You all will definitely understand. Please go through it, since back propagation is used in improving the accuracy of predicting, like predicting in machine learning. It's imperative. It's very important that we understand how it works. Okay. All right, good kids. I know you all will make an effort to know more. Okay, so this particular, I wanted to mention the link, and this screen or whatever I am sharing is also there. Okay, so once you're done, just get in there. He has explained it so beautifully. So please go in there and, get more knowledge, gain more knowledge. Okay, slide number 6. Perfect. Again, it's another excellent link, very motivating author. Okay, please do not miss reading his insights. So the typical loss functions are generally referred by the name entropy. There is code and analysis done in this article. Okay, as if he has submitted a thesis, so beautiful. During our practical part, we'll be seeing similar such code. But otherwise, this is also like for your own knowledge, you can get in there. Do not get intimidated. Please use these. You will definitely understand. Let's move on to slide number 7. Cool. In artificial neural networks, okay, an epoch, like epoch, some people call it epoch, or epoch, refers to one cycle through the full training data set. Generally, you said this is Jiffy, it's beautiful. This is also there in the article. Okay, I think I shared this site already, towardsdatascience.com, right? Now, I have a lot more to talk. Okay, sorry. So, generally, training a neural network takes more than a few epochs. Okay? So, if we feed a neural network with training data for more than one epoch in different patterns, we hope for a better generalization when given a new unseen input test data. All right? One epoch is normally has more than one, it has many more iterations. Now, this article clearly explains the difference between iterations, batch size, and epoch. So it has a little bit code, it has all of this. Now, normally, like I said again and again, epoch normally has more iterations, and iterations are the number of batches or steps through partition packets of the training data. We have mentioned a link to another, this is great, right? You have to definitely get in there. Now, I know these concepts are all important, my dears, That's why I keep on insisting. I'm so sorry. But we have to know these, okay? Batch size, that means total number of training examples that is present in a single batch. These 3 graphs that are given there reflects the scenario of whether the model gets overtrained, overfitting, or not enough training, underfitting, or when it's optimally trained, optimal. Okay, perfect. Let's move on to slide number 8. Wow. So much more for you all to look at. So I'm going to be a little bit slow when I'm talking. Okay. Feed forward neural network or artificial neuron. Simplest forms of, neural networks, where the data or the input travels only in one direction. That is front propagated by using the classifying activation function Usually the example that's given here is the X-ray image fusion is the process of overlaying two or more images. Okay. After that, the next is the radial basis function. Remember, in today's session, we have only 3 topics to talk about: neural networks, TensorFlow, and Keras. But still, we have so much to know. Oh my goodness, there's so much theory to know. Okay, statistics people, statisticians, they would have been really blessed already to understand all of this. But as engineers, we have to pay more attention. We need to get used. A couple of times you take a look at it, you would know. At least we don't have to do the statistics by hand, or we don't have to develop. It's already there. All we need to do is just use the model. So it doesn't hurt to know what type of thing is used where. Okay, cuties? Now, radial basis function neural network. Consider the distance of a point with respect to the center. So that's why this, you see, they have 2 layers, typical order of the power restoration system. That's why that example is given. Again, please make a note of this. And then moving on to next, recurrent neural network. Now, this works on the principle of saving the output of a layer and feeding this back to the input to help in predicting the output of the layer. The example is text-to-speech recognition. Beautiful. Okay, so moving on to the next slide. Now, great. Slide number 9. Convolutional neural networks, CNNs. They are similar to feed-forward neural networks, where the neurons have learnable weights and biases. This is used in signal and image processing, and it predicts the future growth and yield of a particular land. That's why it's given there, you see, in the bottom. Good. I think that's enough time. That's how much slow I could go. I'm sorry. Okay. And then next, we have the self-organizing neural network. Kohnen. I think it's Kohnen. Yeah, it's the self-organizing neural network. The objective of this map is to input vectors of arbitrary dimension to discrete map comprised of neurons. The neurons closest to the point is the winning neuron. And the neurons connected to the winning, we calculate the distance between the point and the neurons. The neuron with the least distance actually wins. So that's why you see the jiffy. Now, all of this is beautifully put in analyticsindiamag.com. That's why I have the link. Please go through that. It's perfectly said. Okay, no better explanation can be given. So it's outstanding. All these articles that I'm sharing are just the best for you to understand the concepts. Once you know that, then you can always suggest me or anybody else with more articles like that. But as far as I know, this is beautifully put. That's why. Okay, beautiful. Let's move on to slide number 10. Wow. TensorFlow and Keras models. I'm going to be pausing for one moment so you can take a look at this. We'll be seeing this in our practical part. Okay, you see how the images are pre-processed and then the model is trained with part of the things. I'm talking about the TF, that's TensorFlow. It's just like that's the icon. Again, it's Google. Some kid asked me, whether to use Google Colab or on the first day. Let's not forget Jupyter Notebook, is the best. Okay, in case you want to use other things, from the beginner standpoint, Jupyter Notebook would be the best place. Okay, cuties. I think you looked at it, this slide. On the other next, part of the slide is the Keras neural network sequential model. You see how all of the input layers. This is the example that I spoke about yesterday. The IMDb website. We are also going to see that today. It's going to get really interesting. The practical part is going to get really interesting. Okay, let's move on to the next slide. Cool. Natural language processing, or the NLP with TensorFlow. We all know that NLP is used, the module, is used for speech recognition. So whatever I say, the personal assistants in my home, like Alexa, Siri, and I don't want to say the other name, Google, they are here in the room. So they're just going to say, hi, how may I help you? So Alex is upstairs, so that's why I called her, and she would not have heard me. Anyways, the corresponding appropriate modules are there. They are able to control, my TV. They are able to play the program for the children. They are able to actually switch off the lights. I did all of this in the artificial webinar, intelligence webinar, turning off the lights, and then like playing whatever YouTube video I wanted on the TV, and then checking the weather, all of that, and then playing music. It can do much more. It can even call people. We call all the local numbers, the United States numbers. You can just call. And the other day, my son got surprised because it recognized him saying, "Is that Kavin?" And he was like, "No." Oh my God, mommy, it's so creepy because I'm so scared of, like Alexa knowing me by my voice. So that's how much training it receives. Globally, people are feeding data, and it's just getting smarter and smarter and smarter. So this architecture is NLP, natural language processing architecture with TensorFlow. Okay, let's move on to the next slide. This is so much fun. Okay, this is a fantastic last slide. I thought this article might interest electronics engineering students like you all, my dears. This is beautiful. It just explains. Please go in there. It would explain. This is how. Getting back to the kid's question, he was asking me whether he could use Google Colab. I have actually, after I put this, I thought about that kid's, the question from day one, and I actually updated the comment in day one. Maybe if that kid is listening today, maybe he can refer to that comment and, like always go in there. So this article is going to be talking about the how GPUs, right? GPUs are used instead of CPUs. Now, TPUs, Google Colab actually is much more quicker, they say, but still this is a comparison that's being done, which is why I thought, electronics engineering students, you might like this, and maybe you can please think of creative projects. There are so much projects that you can do with Raspberry Pi and stuff like that. I know I was watching the webinars from our dear Dr. Arun sir. There's so many beautiful webinars that are being done for you all by your great professor, Dr. Arun sir, and all the other professors. They have all of the latest things like LoRaWAN. I think I saw, they were talking about LoRaWAN. Please, think of integrating your knowledge, your electronics knowledge with Python's, like acquired knowledge. You are like the best because you're a combination of, electronics and computer science. So computer science kids, maybe they would not know how these things work, but electronics children, even though your curriculum is tough, I understand it's tough, because even as a computer science graduates, we have electronics papers. We understand how difficult it's to really get full marks, right? It's very, very, very tough. In programming language, I have mostly seen many people get top marks, like almost 95 even in theory, but electronics is tough. So please use your electronics knowledge wisely. Look at this article. This would shed more light on what's happening right now. So that's why I wanted to put this as a final slide. Okay. Let's move on to the practical part now. I have everything open, so I'm going to be closing this now. First thing first, let me show you TensorFlow. I wanted to show you TensorFlow. I think I forgot to open that. Let's just go to tensorflow.org/guide. I'm just reading it so that people that are on YouTube won't be able to see, right? That's why I'm reading that. So I'm going to TensorFlow, www.tensorflow.org/guide and /tensor. And this is going to get me to, well, it's going to get me nowhere. No, it's getting there. Okay, see? This would be your official, tensorflow.org would be your official thing. And then we are going to be talking about most of these things that are in here, okay? You would know we referred to NumPy. The reason why I framed the syllabus that way was, I wanted, even though we are discussing a lot, still if you know some, you can correlate. So that's how progressing, our courses. So we saw data frames, we saw all of that, we saw NumPy, and we are coming here, right? Now, beautiful. This is the place where you can go and, you can refer. We're not going to, so it's talking about rank of the thing, please feel free to go there. And then I'm going to get back because we have to look at our program. Let me go to, where is that? Let's just click on. I have TensorFlow here. I don't want to waste time. I just opened everything already. Okay, beautiful. So this is the place that we are going to right now. Okay. Word embeddings. This project of TensorFlow, yesterday I briefed about, right? In addition, we saw NumPy, vectors. The reason being machine learning models takes, sorry, let me maximize this. I'm sorry. Okay. It's zoomed up. I hope you are able to see. So what I was saying was, yes, machine learning models take vectors. We saw, that's why we saw arrays yesterday. So it's not that I wanted to teach you linear algebra for no reason. Because of this is why we saw it there. Okay. When working with text, okay, so arrays of numbers or vectors, they are taken as input. And when working with text, we have to first vectorize them. That is, we need to convert the strings into numbers before feeding data into our machine learning model. Please, understand this part. So all machine learning models take vectors or arrays of numbers as input. When working with first we have to vectorize them, and then we have to convert these strings into numbers before the data is fed into our machine learning model. While there are many strategies to achieve this, we are going to adopt the word embeddings. You see layers.embedding there. You see that? So it's an efficient, dense representation in which similar words have similar encoding. okay, or given similar encoding. So an embedding is a dense vector of floating point values. I ran all of this. If I were to run all of this, it's going to take like 2 hours, maybe 3 hour sessions. That's why I ran all of this for you all. So whatever you see, already you guys, you kids are familiar with, how Jupyter notebooks work and how the output is displayed. You see the floating point, this is the output. Okay, so I ran that part of the code snippet, and then this would be the output. So I hope you understand, you're following me. Now, each word is represented as a 4-dimensional vector, a floating point value. And another way to think of is an embedding as a lookup table, like it's sort of like a lookup table. After these weights, have been learned, right? We can encode each word by looking up the dense vector that's corresponding to in that particular lookup table. Instead of specifying the values for the embedding manually, there are trainable parameters, okay? Weights, usually when we see the word weights, that are learned by the model during the training in the same way a model learns weights for a dense layer. It's common to see the word embeddings that are 8-dimensional for small data sets, okay, up to 1024 dimensions. It's just highly impossible for us to imagine, when working with large data sets. But that's how smart, the machine learning model is. A higher dimensional embedding can capture fine-grained relationship between the words. But, it takes a lot more data to learn. Okay, so I think I briefed about all of this now. Let's go to word embeddings. I want to show you here before we take a look at. So that's pretty much it. Whatever I was able to convey, everything in concise. Please go to tensorflow.org tutorials, text word embeddings. So that's why I had them saved here, and in the Jupyter notebook I had, so that's a little bit bigger for you all to see, right? That's why I had that on top, and I was, like while I was talking, let you all to look at it again and again. And then I also show, in the screen, you also have the GitHub. You see, that's where the data sets are available. So please utilize the data sets from GitHub. Also, you can go to Kaggle for, data sets, please. Now, this part of the code is again taken from our, what is that? The TensorFlow website. And it's so many teachers, so many YouTubers, so many teachers, there are great, like teachers in YouTube. Okay, they're really smart. They go over patiently, like one, they type and then they talk. But these, I'm going to show you one, right? Let me look, this person, that's why I put an remember the first day we saw how to embed, like in Jupyter Notebook. So you're going to be looking for him. Okay, he's a really like a great he's great in explaining deep neural networks and everything. His name is Phil. You can go there, just look for TensorFlow, and look for TensorFlow, Phil, and then you'll be able to. But anyways, when you look at, when you just pause your video, you can actually, like look for this, how to get started with natural language processing with TensorFlow, and you can actually get in there. Now, let me go. This is all something that I ran. Okay, let me just go up. Okay. Okay, kiddos. Okay, we are utilizing IMDb reviews subwords 8K. That is actually the data set that we are using. We are training, we're splitting, we are using, look, TensorFlow data sets, Okay, that is what we are importing as TFDS, and we are using, this freely available data set. We are actually splitting. We are splitting that half for training, half for testing, and this is pretty much the code. The rest of the code, so this is all, like Google Colabs. Again, all of this is available here. Okay, please feel free to go in this place, and then word embeddings, you have explanation. See, whatever I said so far, there's so much more talk here, but I just put them briefly together for you all to understand. I hope you understood. I hope. Hope is always there. So now look, this is the code, right? This is the code. Okay. And we ran it here. So even there is a warning. There's a warning that TFDS data sets text coding is deprecated and it'll be moved in the future. So you use this. That's what I got over here too when I ran. So it's saying, please use this. Now, let's not even bother about as long as it's working now, it's going to get, they're not going to support anymore, but now it's being supported. So just for understanding purpose, you see and then you see you see and. These are all the words, that it is taken from it's commonly used, right? Like the articles and the conjunctions, it's just listing on the dots and the commas. It's actually listing. So in here in the code, we are asking the subwords, the encoder subwords, and then I've just given not me, the code. We just basically copied, and so did the other person. He typed everything, and then he actually did explain each part of it. But whatever he explains is in video, and it's available here as text. You can read at your own leisure. It's not going to intimidate you. My dear professor from college, he saw our thing yesterday, and he said, I was so interested, Ma, but some of the kids, I think they might be scared. So please call me for feedback. Then I said, I just saw that a couple of minutes back in the phone. Then I said, yes, sir, definitely. I'm going to call you over the weekend for the feedback. But my intention is never to intimidate anyone, but that's how much we need to learn. Okay. I don't want to call this as Python practical training and not discuss all this. So I want to give heads up on everything. It's up to you. You can learn at your own pace. I'm giving you enough resources. You can always get back to me. I have specified my email ID. I don't generally get on WhatsApp. I've seen other people get on WhatsApp. I don't generally take much calls. So that's why email would be a good thing. You can always connect me with me on my network in LinkedIn. So getting back to this. So now look at the code, right? This is the code that is going to train and validate. Now I have to minimize a little bit. I'm so sorry, my dears. I have to minimize a little bit. Okay. So this is look, this whole thing is our output. So we were talking about EPOCH, epoch, however you want to call it. Okay. Now, this is on my ordinary, it's not even like a GPU based system. It's just my it's a sturdy laptop though. When compared to other laptops, this is a sturdy one. That's why I'm using my presentation. It was able to take all the load. I have like lots and lots of things that I have for, especially for this Python training, and it's able to take all the load. So what I meant to say was this, maybe when the YouTuber runs that, he might be using the high end, the GPU powered, like PCs, or maybe the gaming PC, that kind of thing, really sturdy. But we were able to run all of this on my laptop. So I'm positive that, you can also, you don't have to wait for the infrastructure, I'm positive you can run it in your college or, in your home. Or if you cannot, then, always refer here to get an understanding. Even here, they have run it. And then you see, They have, you say, I mean, say over here. Yeah. So they have trained the model. Explanation is beautiful, you know. You don't have to look any further. I know there is so many different places, you know, asking to, you know, like pay money. You know, we would teach you this. First, utilize the free resources. You learn yourself. You ask your friends. You ask your teachers. You know, you ask resource people like me, or you know, whoever is going to be a resource person on the future webinars. That'll be the starting point. The more we get used to knowing these things, you know, the better. Yeah, you know, I don't recommend going to any class and, you know, paying, wasting your parents' hard-earned money. Please, money is precious. Time is precious and money is valuable, I mean. Okay, your time is precious because you need to concentrate on your curriculum as well, right? Coming back to this, I'm going to not leave this zoomed so you can take a look at. There was a reason why we learned graphing yesterday. You see the graphs? So the dots over here is the trained one. The actual thing is validation. So the model ran, it trained, and then it validated. I'm going to, it will be interesting. We have combined, look, in the code, we have combined. We learned already the, initially the first day you might be wondering, you know, why did we even go with the IO modules? There is a reason why I put the IO modules then. I know when we started the first day, there was a lot of people that was interested, and then little by little, you know, we saw there was not much people. But there is a reason why I put some modules prior. See, because we need to know that in order to understand this right now. So in order to understand machine learning, we need to understand a combination of all of the, you know, other days work. So the graphs, you see, the graph. So otherwise you'd be wondering, how did I even get that, right? I have problems with minimizing with, okay, touch screen, right? Okay, anyways, so this is the accuracy and the, I don't know if you're able to see accuracy and how accurate it is, and the epochs. Now, over here, what I meant to say was we are writing this information in these TSV files, the tab separated files. Let me show you that. I don't want to waste time, so I opened everything for you all. Look, this is our TSV, the vector TSV file, and then the meta TSV file. I don't want to scare you all, but I wanted to still show you this, right? Hold on, let's just go to let's just say let me just CD there first. Okay, the other file is still big. I want to just do meta.tsv. I know it'll be very little for you all to see, but what I did over here was, let me copy that, and I'm going to show you in you know what? I don't have to even copy. Let me talk. I basically typed this file. I wanted to know what all was in there. Okay. And then I see all these words. Okay. There's so much. There's so much words. All of this is taken from our data set. And I did not have this file. You know, it was created. You see, I ran it and it was created here. Getting back to the code. Okay. So we are opening these two files in the write mode. And in what format? The UTF-8 format. That's why we saw all of this on our IO module. Now, we are attaching weights, as I explained. And then we are writing every word with the new line character. Let me minimize this. Ravi sir is there. Okay. Now, We are training the model based on the epochs. Now, when I ran, the code only has 10 epochs. So look at this, epoch 1 out of 10, and it's doing this. And how many, it's the laws over here. I'm so sorry I have to show it like that, okay, even, okay, because it's a lengthier line. Okay, you see? So this is our machine learning model. Our model is getting trained based on this, and the accuracy is displayed here. Now, what is the result of that? The result of that are the two files. Now, where am I going to show you? I am going to show you in the projector. This is a cool place. TensorFlow, right? It's Google. So let's go. Oh. There. Projector.tensorflow. Look, these are all our words. I already did. Look, we can actually load. We can hit on load, and then we can actually specify our TSV file of vectors. So I'm going to be choosing the file, our TSV file. So let's just do okay. And then here, the metadata, the file that I actually displayed. Vector file would be all floating point, based on where it has to plot. Yesterday, I showed you some examples. I showed you, how vectors work and all of that. This is the real data set, that we took, and we actually trained it, we ran it, and then now click outside. We just have to click outside to dismiss. This is our thing. See? I'm not sure if you're able to, I'm sure you'll be able to see. Look. These things are all words. From the database, the data set, For now, it's written in our file. And it's vectorized. Code is explained beautifully over here. See, they also ran similar to how I showed in Jupyter Notebook. Okay, and then see, they have shown the same thing. They've taken a screenshot of it. I showed you live. So let me get back here because I need to show one more example. Oh my God, it's getting delayed. Okay, so you go on projector, tensorflow.org, and this is another, in case you're not able to follow, he types when he does that, and he talks, he explains, so you can take a look at that. So the starting point would be there, the word embeddings, TensorFlow tutorials, text word embeddings, and then go there. Okay, cuties, I'm going to show you one more Keras model. I hate when this happens, the stop presenting happens. That's what happened to me the other day, where I was so perplexed the second day. Okay. I'm going to show you the other in Python shell. So even here we can run it. I wanted to show it to you here. I think I have the code also open. Yes, I have everything open. Good girl. I am a good girl. Okay. All right. This is, what do I do with that? Oh, I don't want that to, oh, there, it went away. Okay. Keras, I'm importing Keras. So this is our neural network with Keras tutorial. Okay. What we're doing here is we are actually, so this is our data file.csv. I'm going to be showing you that file. It just has some, some numbers. Some numbers, you know. Maybe should I show that, or maybe I should just... So there is a CSV. Yeah, this is the file. I think I closed that file. Sorry. I'm not that good girl. Okay, just five lines. Okay, just a few lines of some numbers. Okay, they mean something like medical values, but we can actually think that this is maybe like relevant to game or something. Let's not scare people now, especially when the whole world is talking about the pandemic. Okay, well, let's not talk about anything medical related. This is like, let's just hope the data file.csv is talking about it's talking about some game, some score. Let's just think that maybe it's just talking about some gaming and some scores. Okay, now what happens here is I'm going to be explaining while I let you look at the code, and in the background here is what I ran. I want to show you this. There is a warning. I want to explain the warning as well. That's why I'm keeping it like that. So we load the data from the CSV file, then we define the Keras model, we compile the Keras model, we fit the Keras model, we evaluate it, and we, make the predictions based on this. Okay, as simple as that. It sounds simple though. NumPy library loads our data set. Okay, so you see NumPy. You see I have imported from NumPy, and then I'm loading the text, the file based on load txt. Okay, I think you can see that. If I highlight to, that thing comes. That's why I don't want to highlight. Now the data set is given. It understands the data set. Now, as such, we'll be, using two classes from the Keras library to define our model. Okay, those are the models and the layers. Okay. And the binary classification problem. Okay, this is a binary classification problem. So this predicts, a game win as 1 and not as 0. Okay, let's just assume that way. Like I said, this was medical data. So if the person has something, then, it's a 1. If it's predicted, then it's a 1. If it doesn't predict, then it's 0. That's how it is. But, I'm just changing it. We'll predict as if this is a game that we're running. And then win means 1. When we see 1 as the output, that is win. And, 0 otherwise. All right, let's just say. So that's all the code. There's no more code. That's it. Our code was just one page, but I just added these few lines extra in order to get rid of the warning, and I actually ran them. If I run them, it's going to take a while. That's why I ran them and I kept it there. I didn't want to even close the thing. What happens here is all the, let's assume that each player, the input variable is each player's thing. Okay, so we use it directly with our neural networks, and we expect the numerical input and the output values. Okay, so that is why this is perfect for Keras. Look at this, right? Let me show you. This is the output that I have when I used model predict classes. I'm using that model predict classes. However, it's saying, you have used that as a warning. It's just not error message. It's a warning. So this is how our model got trained. Something similar to what I showed in TensorFlow. You see, the same thing is, it's just the same thing, same exact thing. Let me show you right from here. Okay. So I wanted to also do another thing today, but anyways, I'm gonna give you the link because it's almost 8 o'clock. I'm gonna give you the link so you can take a look at that. It's very beautiful face recognition project. You can look at that. So this exactly is how our model got trained, and since we used this method, it's saying that, your output, is great, but the thing is, there is a warning, so better change into those other methods. So just keep those two things, okay? Just predicted. Okay, there. That's not right. Okay, that's so. So this is all, you see, epoch. And there, and the other example, we just saw only, I think, a few epochs. Here, it's 150 epochs. Okay, it's running that many times with the accuracy of, see, it ran, and then finally the accuracy is just one. It just is like 100% accurate almost. Initially, it was not. And then, so again, it depends. Every time it just depends. When you start running the code, then you will know. Now let me show you the final thing. Look at this. I want to show you this. See, it's expecting a 1, but this is 0. It's expecting a 0, and it's 0. So that means this is not, it's not so well, this is not so well working when we give a real-time data. This model, okay, this model, meaning I used 3 different prediction styles. That's why I put them all here in the notepad, for us to talk about. So when I use this multi-classification, okay, this was actually specified by TensorFlow, since it's saying you were using, let me get back to the code, you were using just this, the model.evaluate. Model.evaluate is, it's a warning, it's going to be deprecated. We're no longer going to support this after 2021, some date it just gave me, I forgot the date. So you have to make use of either this one, the model.predict classes, this one, or you have to use this one, numpy dot argument max dot. So when I gave this, for our case, we never got the expected results. However, when I gave this particular thing, it mentions perfectly, our look at that. First scenario, it expected 1 and it got 1. Other scenarios, it expected 1 and it got 0. It expected 1 and it got a 0. That means the prediction was not correct. So we can talk about overtraining the model, undertraining the model. We can talk about all of that now. If our model was overtrained, then the prediction, see, this, it's been overtrained. The prediction and the values are matching here. Predictions and the values are matching exactly. However, in this case, it's not. So it's just simple few lines of code. We are importing Keras models, Keras layers, and we are loading from our data file. It's a simple comma separated CSV file. That's why we had this is again called what, the other example, and this example is like web scraping. That's data set. A data set is completely taken off from the words that are part of IMDb. We accumulate it, we train our model, we do these things. Okay, in order for us to train a model, we need data. So for that, we're going to be scraping. That's some kid asked me, what is web scraping? So that's what I'm just explaining now. So this you see in action. Okay, before we conclude for the day, I want to show you a link where you can see similar code. Okay, this is no use for you all anymore, and maybe this you can take a look at. And this is, you can train a model from Python shell. You can actually do it from TensorFlow. You can, use other, PyCharm. PyCharm was, I'm going to be showing you PyCharm, but I want to first, familiarize you all with these two first, these two environments first. Now, let me get back to here. Okay, I wanted to show you. Please make a note of this. This is pypi.org project, okay, and then phase hyphen, not underscore, recognition. Okay, so look at that. This is an enhancement project, and you see the this was before, this was done before. That's why President Obama and Joe Biden, then the vice president, they are there. So the picture, look at that. Even from the phone, it recognized. I wanted to show it over here, but lack of time, anyways. You can always look for the code that's here, how they run it. There is GitHub references. Look, everything in here. They're loading the file. It's too little. Okay, let me see. I think I can zoom it up here. Good. Okay. So go on pypi.org. Okay, I think we already know about this. pypi.org. The other day, the second day, I was trying to get in here, and then there's so much confusion, right? I hope you remember. Some of you who are like in all these sessions would know. So here we are using face recognition. It sometimes this would not work well in Windows. Even here they have mentioned, I want you to like take a look at many examples like this, use the code that's there, copy them, paste them, and then look at this. Even the face from his phone, his iPhone or whatever phone, I think it's an iPhone, yeah, it's able to recognize. Okay, and then it says that's the president, Barack Obama. So that's how cool face recognition is. Face recognition. It's, again, you see, pip install face recognition. We don't have to write code. It's beautifully written. All we need to know is just have to use it. Okay, kiddos, are there any questions today, sir? Happy weekend. I will be bothering you all only
yes,
Monday. Only Monday.
Madam, only one.
Yes, sir.
Hello,
Yes,
madam.
sir. Yes, sir.
Only one question is there from Nataraj Das.
Oh, okay, the famous person who keeps on asking about pointers. My dear Nadraj Das. Yes, sir.
Yes.
What is the question?
Question is this face recognition similar to darknet YOLO?
What is it? Is it similar to what?
Is this face recognition
similar
to darknet YOLO? YOLO? YOLO.
Probably darknet YOLO. Yeah, darknet yellow. Okay, maybe I'm not sure of that, sir. Maybe I will get back to you, dear Nadraj Das.
Yes.
On that in the comments, I'm going to mention it to you. Other than that, do we have any more questions, sir?
No, madam.
Utilize. Okay. Please utilize all of these, the things that I said. Tensorflow.org. It has beautiful explanation. One more thing before I forget. I want to show you this. Okay, let me copy this, and I want to let me put it in a notepad so that you are able to see bigger. Let's see, or maybe I will do it in. Let me do it here. Okay. Where is our thing? Did I close it? Oh. Okay, let me copy this and paste it here. Maybe, is that big enough? Is that big enough? Is that big enough for everyone to see? PyImageSearch.com, and it has a regression with Keras. This is, I'm going to be pausing for a second for you all to make a note of this. It's www.pyimagesearch.com/2019/0121 regression with Keras. Okay. This actually is predicting the house prices. Okay. See, he has beautiful explanation. He is, coming up with comparison between the models, and he's, like, this is the data set, and he has, given which all, look at this. install the installation in Ubuntu or Mac OS. He has mentioned the data set. He has mentioned code, the project structure. He has, even if you don't do it, just if you read, you will be able to follow and get an understanding of how these things work. Finally, this person has mentioned he must be conferred many PhDs actually. I'm awestruck by these brilliant people that are bloggers, but still I don't know their background though, but they're so good. And like, look at that. So he finally, his thing predicts. So he has also ran. See, look at this. He has ran and then he has copied that. So even if you don't copy the code and if you follow this, you would get a clear understanding similar to the Keras. This is from the website. This is actually data set. This is regression. So meaning it's predicting the values of the house. Some kid, I remember, asked me for a data set. He was in India. He was doing a project. He was a school kid, I mean. So then that's how I happened to, realize that, okay, we can suggest Kaggle to everyone. Because during work, we don't, go look for things, we work on our projects, we have our own data. But when during webinars, when such interesting question comes is when I am interested to know more. So kaggle.com is another great place where you get data sets. So I suggested, that kid also was asking for regression. Now that it rings a bell to me, then I suggested Cardeco. There's a website, right? Cardeco.com. There, that had the data set of the cars, the used cars, and the value, and he was going to run that and predict the prices of so it's interesting. It's very interesting once you get in there. Some of the links that I shared, the guy, the person that I said, he's very motivating. He said for many years, it seems he would just go on day and night without break. He'd come back from school and then run it, and it's so interesting, for me to know, what's going to happen. That's how he said, sometimes I just go without sleep and then get back to school. That site that I showed you with when I showed you the slides, please get back there. It's beautiful. Complete explanation is given. Similarly, this site, you will be able to understand machine learning models so well, from where, how, what is happening, etc. Like a broader picture with code, with explanation, as if someone is sitting and explaining to you. Okay. And you can also ask him questions. See, many people have asked questions. I see some Indian names also, some Indian names as well. They asked questions and he responded. So please utilize such good resources. I think we went over time. Sorry. Thank you so much, everyone. Andarki namaskaram. Chala santosham. Meeting you all this whole week and torturing you all. We'll see again next week. 2 more days and that's it. You're
like
off
that,
my head.
It's not like that, madam. I hope every participant has enjoyed these days, all these 5 days for your wonderful sessions.
Thank you, sir.
Thank you, madam. Have a nice day.
Thank you, sir.
And also happy weekend.
Thank you, sir. Thank you, sir. I'm looking forward for the weekend to enjoy with my kids.
Oh, sure.
Thank you. Thank you, sir. Thank you, sir. You all enjoy.
Thank you.
Yes.
Okay, information to all the participants. So the next session will be on Monday. There is no session on tomorrow and day after tomorrow. So I request you all to join on Monday at the same timings by 4:30 p.m. Thank you all.
Thank you so much, sir. Namaskaram. Thank you. Thank you, everyone. Thank you. Happy weekend. Thank you, sir. I'm signing off now. Thank you.
Thank you, madam. Once again.
Thank you, sir. Thank you, sir. Thank you, Arun, sir. Thank you so much, Dr. Arun, sir. Thank you. Thank you, HOD, sir, and everyone. Thank you.
Yes, madam. Thank you.
Thank you, sir. Thank you.
Ah.